Welcome back to Diesel Talk with Tony Salas. Here to talk to you about the Duramax LML Piezo Common Rail Injection System. We're going to talk about this injector right here, and what we're going to do is pretty much explain the Common Rail system. It differs a lot from the previous models of the Duramax that are the LMM all the way back to 2001 with the LB7. So this started in 2011 model year. What's unique about this Common Rail injector is that it shares pretty much the same design, if not the same, almost everything is the same, on the Power Stroke 6.7, except that the Power Stroke 6.7 uses a lip pump while the Duramax still works on a suction side, low pressure side. So therefore the lip pump itself, it's still bolted to the back of the CP4 injection pump. So we'll talk more about this, but yeah, that's the biggest thing we got to pay attention when it comes to the LML and the LGH Duramax, is the fact that they put the lip pump on the back of the injection pump. So if you're familiar with the Duramax LB7s all the way to LMMs, those were solenoid style. So there's no solenoid in a Piezo Common Rail injector, it's a Piezo element, but we'll get into that here as we move along with the presentation. But please understand that it is not solenoid, so therefore, you know, it's a lot different in operation. So, well, let's get started. Okay, as we get started talking about this Piezo Common Rail injection system, we're gonna go ahead and get started here talking about the Duramax Common Rail injection system. As you can see on the screen and behind me, the injector is relatively long. Again, you can see right here that probably primarily the most important thing you're going to see in the front is, or the top of the injector, is the return line. And you also got the high pressure fitting there on the top. So that's the biggest thing you're going to see on this. So we'll get going on this, but this is a Piezo Common Rail injector there for Bosch. Again, same thing used on the Power Stroke 6.7, but we're going to focus on an LML LGH Duramax fuel injection system, as you can see here. So as we look at the system itself, everything starts with understanding the three different departments of a common rail. Most of you that have seen my videos know that I talk about pretty much the low pressure side, the high pressure side, and then the return. Okay, so there are a lot to chew on here as we look at this diagram here. Oh my God, we got a lot going on here. So in this case, we got the hydrocarbon injector number 14. As you can see right there on the upper left hand side, you should see another injector, which is a low pressure hydrocarbon injector, and that injector is designed to inject to the exhaust, and that is for regeneration purposes. We want to throw fuel against the diesel oxidation catalyst to generate those temperatures that we need for burning the soot in the diesel particulate filter and provide also warming of the exhaust. So, and once again, you can view another video on that. But again, that is the hydrocarbon injector number 14, also known as the 9th injector there. Okay, hydrocarbon injector, 9th injector, all the same thing. So first of all, again, everything starts with the low pressure side. This diagram that we have here, as I will show you here with my cursor, as a matter of fact, let me switch over to a little laser pointer. You're going to see we got two fuel tanks. One, this is for a vehicle that has factory dual fuel tanks. You know, I understand not all trucks have factory dual fuel tanks. Aftermarket is different. Now, this is factory, because you're going to see on number 8 right here, you're going to see that number 8 is a transfer pump. It transfers fuel from the secondary tank over to the primary. But if it does not have dual factory tanks, then you're working with one big primary tank, right? So the other thing you're going to see different is number 10. This is for Savannah and Express vans. Savannah Express vans do have a lip pump, believe it or not, and they also got a preliminary filter there as well. So therefore, that is number 10 is not on a Silverado or Sierra GMC pickup. So again, not found on that. But number 12 still is our traditional filter. So understanding fuel systems, when you look at these kinds of diagrams, is understanding like following a map. You follow the flow. So obviously everything starts at the tank, and we go out of the tank and we go past the filter assembly from our test port all the way up to the CP4 injection pump. So yes, we are using a CP4 injection pump. That injection pump is rotated by the camshaft, and in turn it rotates and generates rail pressure. It pressurizes the fuel. That fuel is sent, as you can see, there's two discharge lines, one here and one here, going to the passenger side fuel rail. And at that point, we have a separate line that serves or distributes that same pressure going to the driver's side rail. But on number 11 and number 5, we're going to see two key components. Number 11 is going to show you the PCV, which General Motors likes to call the fuel rail pressure regulator number 2. Fuel pressure regulator number 1 is found there on top of the CP4 injection pump. I like to call them volume control versus pressure control, just like we see on other common rails, because that's what they're doing, you know. In this case, the CP4 on the injection pump here is controlling the volume of fuel going to the plunger assemblies, right? While the pressure control valve found in number 11 at the front of the driver's side rail, we'll show you a picture of that, don't worry, that is relieving high rail pressure. So it is seeing high rail pressure, while again, the fuel rail pressure regulator number 1, which I like to call the volume control valve, is controlling the volume of fuel coming in from the lift pump assembly. So, but excuse me, this is not a lift pump assembly. It is pretty much a suction pump that sucks the fuel and pushes the fuel into the injection pump. At that point, we see the injectors, and all the injectors themselves are injecting fuel controlled by the computer itself. So the fuel injection control module and the computer itself are all housed again in one single unit, which is all part of the ECM engine control module. The most significant thing you're going to see on the LML is that they're using an orange wrap, kind of like the plastic, we call it accordion wrap, that goes around the injectors. And what we're doing there is that we're actually letting you know that is a high voltage. That's what General Motors wanted to do. So if you're wondering why is there an orange reddish accordion wrap around the injectors, is because they wanted you to know it is high voltage above 120 volts AC, DC. So please be aware of that. But we got return. So therefore, what you're going to see is you're going to see the return coming off of this bank of injectors coming here, follow the pointer. And we also see return coming off of these injectors coming off of here. So therefore, they join together at this junction point, where that return will join with the return from the injection pump. So here we see the return from the injection pump and return from both injectors. And you're going to see it goes over to number 4. Now that number 4 is a little interesting because it also gets the return or the dump pressure from fuel rail pressure regulator number 2, where it dumps excess pressure, and it also joins the return. Then at that point, it sends it all back to the tank, but some of it is maintained pressured somewhere around 55 psi, and it actually sends all the way back to the inlet of the suction side of the pump. So therefore, we're pulling that fuel back in. So yeah, that's one thing you got to understand about these piezo injectors, is that they need some kind of return pressure for them to work. So yes, they need some return pressure in order for these to work. So you can't just disconnect them and try to see if they work. No, it will not work unless it has some kind of return pressure, which is again somewhere around 55 psi. That's what we're going to see. So now, when you look at overall at the front of the motor of an LML, it's going to be a little tricky, but you're going to see that there is a plug right there, and that plug is designed to be removed. When you take that whole assembly off, you don't have to take the whole front cover off, by the way, when you replace the CP4 injection pump. So if the pump needs replacement, let's say we had catastrophic damage, we had debris all over, please note there is a plug there, and that plug right there is designed for you to line up the marks. There is a set of timing marks you need to set up there when you install the cam and again the injection pump drive gear as well. So, but everything, like I said, starts with the low pressure side. So you obviously know you got your fuel filter assembly. We've been talking about this same one we've seen on previous models of Bosch Common Rails, from the LMM all the way back to the LB7. Again, you got your fuel being sent here from the transfer pump, right? So we got fuel coming in here that's being sucked in, and that suction is continuing on past the filter and out towards the injection pump. So again, that's all a suction right there. That's all we're seeing there, just like our previous models. So therefore, that is what feeding the the injection pump. So therefore, please note that this has something different. It has a switch right here. And as it says here on the notes, it says that the fuel line vacuum reaches greater than 14 inches, the switch will open. And therefore, at that point, you're going to get a message on the dash that says fuel filter restricted. So it takes a lot of suction for that message to come on. That's why, again, we're recommending the change of this fuel filter every other oil change. And if you compare these fuel systems with other fuel systems out there, we're only using one filter on this LML LGH model. So that's the only filter you see there. So food for thought. Here's a better view of that switch, of the plumbing also as well. Again, you're going to see metal lines coming from the other side where we're, again, pulling in fuel. and that fuel's pulled in from the fuel tank, goes past the plunger, then goes out towards the injection pump. But you're going to see a set of fittings right here. So you're going to see a line that goes to the vacuum switch, and then another line that goes over to the test port along going to the injection pump. So if I'm fair here, I start off at metal, then rubber, then metal, obviously, which is the fuel filter housing, then rubber again, and then metal, and then rubber finally going into the injection pump. That's the way they're set up. So given the fact that if these trucks are really aged, they're really old, one of the things you should be doing is replacing these lines. And guys, get them from General Motors or somebody who sells the same similar kind of lines, because again, they tend to go bad, and it's not something you're replacing every day. If the truck has a lot of dry rot like we get here in the desert, you definitely want to replace those lines. So now, like we discussed already, everything starts with the low pressure side. So like we've also been saying, we're pulling fuel from the tank. Again, we go past the filter assembly, there's our test port, and eventually we go over to the injection pump. All that is a suction. So you're still going to use the traditional suction pressure gauge I've shown in the past on previous videos. So again, got to check that suction, again, no greater than 5 inches. You know, 4, if it's 5, they're telling you to change the fuel filter. If it's 4 and under, it's okay. You also want to check your suction under load. Like I've been saying before in previous videos, I said that you want to see, again, somewhere between 8 to 10 inches. If it's greater than that, then therefore you've got a restriction, which most likely could be the filter. Now, if the filter's been replaced, what could be the problem? In other words, there's some kind of restriction going on in the tank where we pull the fuel out of the tank. So we also see that I mentioned the hydrocarbon injector. Please note that that hydrocarbon injector is fed return fuel, not really return fuel, but it's actually injector crankcase fuel pressure. So that's coming off the side of the pump. Yes, there's a banjo fitting right there on the side of the pump that feeds this hydrocarbon injector. Well, like I've been saying for the longest time, when it comes to common rail injection systems, has been the fact that, you know, you're actually using some kind of, what's the word I'm looking for? We're using some kind of, in other words, let me rephrase, I'm saying that all wrong. The number one enemy of common rail has been contamination. So one thing I've always been saying has been to always make sure that you have a clean system. So what has been plaguing these hydrocarbon injectors has been the fact that they are actually getting contaminated or clogged. So one of the things you're going to do with the hydrocarbon injector is to, again, measure volume out of it. There's a test you can do with the scan to see if it squirts enough volume of fuel coming in. So if it's clogged, it ain't going to squirt in much fuel, and it'll never reach those regeneration temperatures. Let me give you an example. I'll go ahead and run a regen on the truck, and it won't go over 700 degrees when I'm supposed to go way over 1,000 degrees. So that's a good telltale. But they are also electrically monitored, so therefore the computer will monitor its circuit integrity as well. So low pressure side. So here we can see a view of that. There's your line coming from the side of the injection pump. Here is the solenoid that's controlling the opening and closing of this injector. There's a line coming out of here. So therefore that line goes out and feeds over to the exhaust side. So therefore we're dumping fuel into the exhaust, like I've been saying for many years. So, but yeah, that's your hydrocarbon injector right there on the passenger side valve cover. So when you look at the whole return side, yes, we did talk about the hydrocarbon injector on number 14, but please note again, you got return coming off of the injectors. You got return coming off of the high pressure injection pump or CP4 pump. You got a return being dumped from the fuel rail pressure regulator number 2 in front of the passenger side rail. And that all goes over to a junction point where we send, again, some of that fuel return back to the inlet side where we start the whole low pressure side, and if not, a lot of that return goes back to the fuel tank. So that's plumbing. So one thing we see a lot about these Duramaxes is the fact that, boy, do we got a lot of return lines, a lot of plumbing going on, so it could be a nightmare at times. Now, as you can see here, if we compare the CP4 on a Duramax compared to a 6.7 CP4, you're going to see that the back, and that's what we're looking at here on this picture, we're looking at the back of them, and you're going to see the fuel temperature sensor located on the back of this injection pump. And you're going to see here, this is that actually is your pump. That's the one that creates the suction. It is a lip pump, but it's bolted to the side of the injection pump. So that's the guy that's sucking the fuel all the way back from the tank. So again, we're pulling fuel from there. Now, I'm not going to lie to you. Given the fact that air and volume are a big problem with Duramax, and there's many vulnerable points for this fuel system to suck air and get low pressure, thus cause catastrophic damage to the CP4 pump, I'm at the opinion that every time I'm going to do a system, let's say I got to do a pump, I got to do injectors, I sell the customer an aftermarket lift pump, like I mentioned before. So yeah, most definitely I sell an aftermarket lift pump, so definitely want to do that. Now, the Piezo Common Rail Injector, we're going to do a separate video on this, but the Piezo Common Rail Injector works on the principle of expansion and contraction. So right here, this piezo on the center is designed to work with high voltage. And when that voltage comes in, it actually expands, but then you reverse the polarity to get it to contract. Again, you apply voltage to get it to expand and get it to contract. So therefore, there's an expansion and contraction within this piezo element, or crystal wafers, whatever you want to call them. The whole purpose is to control a control valve, but there is also a set of pistons in there. So those pistons are designed, again, to create the pressure differential we need to inject. But again, we're going to do a separate video on that because I'm going to spend a while on that. But just understand that the injector needs that in order to inject the fuel. But before we go into that, as we follow the low pressure line coming out, again, here's that line coming off from the filter, and that'll eventually go into the injection pump. So one of the things you got to be really diligent about is following torque specifications of the actual lines themselves. So if you don't follow torque specifications, you're going to have leaks, and that's something that can cause a fire. It could be a hazard. So therefore, every line you see in here has a torque specification. Yes, we use a crow's foot attachment with a torque wrench, and we go ahead and torque them appropriately. Now, on the driver's side, right there in the front of that driver's side rail, you're going to see fuel rail pressure regulator number 2, which I mentioned already we call the pressure control valve. There you see a black and white picture of it right there. It does have a filter on the end, and it can be damaged, but that's the guy I like to remove when I suspect I got contamination. So if there's contamination, let's say it's grenaded, there's metal in the system, where can I get it at? Where can I find it? Well, I have to take a few things off. It's no fun to do, but what I'm trying to do is either take a line off, or you may want to inspect the fuel pressure regulator number 2 again. Now, fuel pressure regulator number 2 and number 1, here's, you can see, here's regulator pressure number 2, and here's number 1 right here, right? Well, we had a situation where we actually had a no start after putting an engine back together, and turns out that the harness, which is not shown here, there's no wire and harness on this one, but the wire and harness connectors are the same for both regulator 1 and regulator 2, and since they're so nearby, it's easy to cross them. And since they were crossed, we had no real pressure buildup. So the way we identified which one went to where was following the wiring diagram and looking at fuel rail pressure regulator number 2 and looking at fuel rail pressure number 1. And then we were able to identify which was which. And sure enough, the wire colors didn't match, so we swapped them. So once again, if you didn't get it, on the injection pump, which I call the volume control valve, fuel rail pressure regulator number 1. On the end of the driver's side fuel rail, the front, you're going to see fuel rail pressure regulator number 2, which I like to call the pressure control valve. Again, that's located right there. That's what controls rail pressure, okay? Both regulator 1 and regulator 2. Now on the back side of the fuel, fuel injector, fuel rail, on the back side of it, in other words, driver's side and the back, you saw the front, fuel rail pressure regulator number 2. Then on the back, you're going to see the connector right there for the fuel rail pressure sensors. So that's located in the back. Again, your fuel rail pressure sensor, the one where we read the rail pressure that's in the system itself. So there's a better view of the fuel rail pressure regulator number 1. It is removable, so we do remove it actually to inspect it to see if there's any metal contamination too. So that's another point where you can check, and it might be an easier point to check where you got any possibilities of contamination in the system. But like I said, I have the habit of taking regulator 2 off, but again, that's another place where you can start as well to check to see if you got contamination. And why would you be doing this? Is you're not building enough rail pressure or not any at all. So therefore, pay attention to that. So there's a different view again of those lines being plumbed in. Again, here you can see the line. This line is the one that actually delivers fuel from this one right here, excuse me. This is the line that goes from one side to the other side. So therefore, we're delivering fuel rail pressure from one rail to the other rail. So remember, they both discharge out of the pump and they come here to the passenger side here. And then you got a third line that delivers fuel rail pressure from the passenger side rail over to the driver's side rail, something you're going to see there. So again, there's our vacuum switch, another picture of the vacuum switch itself. And then we could see a picture of the actual fuel rail on this would be the driver's side still. Now, one thing you're going to notice is that there's two sets of line and they're different from each other. So therefore, you're going to see the other side is the same, but on one side, no two lines are the same. So they're interchangeable with the other side. But please note that these lines are reusable. That's good. You don't have to throw them away. But in this case, you're actually, you know what? I got to look that up again. I believe they are not reusable. So let me look it up. But in this case, I'll put it on my other video. But anyways, you're going to see these lines are delivered over to the fuel injectors. But I cannot stress enough to torque the retainers and also the nuts themselves. So very important that you torque them to specification. Okay. And that's it. So therefore, a basic overview of that. Just understand, let me backtrack here, that it is imperative that you understand the system itself, okay? But in order to build rail pressure, you got to know the system itself. That's why I'm at the opinion you can't fix something correctly if you don't know how it works. So I need fuel coming into the injection system itself, right? I need that. And I also need, again, something to push up against. So as we follow the lines coming out of the injection pump, where is it all deadhead at? It deadheads against the fuel injectors. But there are vulnerable leak points. Just because it doesn't build rail pressure doesn't mean that it's injectors themselves. So one of the things you're going to do is you're going to check to see if there's any discharge coming out of the fuel rail pressure regulator number 2. That could be leaking. You can have also excessive return coming off of what else? Let's see, where else do I got? I can lose rail pressure at the injector. So yeah, we can have injector. We're going to talk about those adapters on a separate system because again, remember I said you need 50 some PSI, 53 to 55 PSI of return pressure. So just because you disconnect it, you can't measure the volume. You have to literally put an adapter to plug that line off. So therefore you don't drop the rest of the lift pump, or excuse me, the left of the return pressure out of the injection system. So we got to figure out how to do that there too. So if you didn't understand what I just said, it sounded like mumbo jumbo. One more time. If I need to maintain pressure here, I can't just disconnect this line, leave it open. I have to block it. So there's adapters they're selling on Freedom Racing and other companies sell you where you're going to go ahead and block it and be able to maintain that return pressure in this return system in order for these injectors to work. But again, we'll show it on the next video when it comes to the LML injector, the Piezo Bosch Common Rail injector there to be built. So there we will also put the pieces together for diagnosing for issues. So that's that. Quick video on that. So therefore, please comment, let me know, and we'll see you on the next one. Thanks for watching.